Have you ever heard the saying, breakfast is the most important meal of the day? What about you are what you eat? Or food is only meant only for nourishment? Or you can't be sad when you are holding a cupcake? Well, whether or not you have heard any of these sayings, you have eaten food before. However, have you ever thought about what happens to the food you eat? Yes? No? Either way, whether you are as cool as a cucumber, a bad apple, have bigger fish to fry, want to be a couch potato, wish life was as easy as pie, are bananas about studying, or take everything with a pinch of salt, you have found yourself in medical school and having to study the alimentary tract or GIT and its accessory organs and how these organs turn something as ordinary as food into components that not only keep you alive, but keep you healthy and optimally functional. Hi, welcome to our video and thank you for joining us. In this video, we shall take a brief look at the anatomy of the GIT. We shall then have a brief look at the histophysiology of the GIT. Excited? Probably not, but by the end, hopefully, you will feel a bit more optimistic about this very important system. Let's get to it. So, what is the GIT? Rudimentary description of the GIT, like if we were playing 30 seconds and had to describe it quickly, would be that the GIT is a continuous tube which extends from the mouth to the anus, through which our food travels from when we ingest it to when we expel it. Is this definition true? Well, yes, at least partly, because the organs of the GIT are examples of hollow viscous organs, and therefore tube-like organs, organs with hollow insides. Yet, we know that this description of the GIT cannot be complete because, for starters, the food we eat looks a bit different when we excrete it from when we ingested it. Gross, I know. All disgust and horror aside, this must mean that the GIT cannot simply be a tube whose only purpose is simply to convey food. Can it be that the GIT is slightly more useful and complex than this? Yes, it can be. And why is that? This is because the organs of the GIT are not simply hollow tubes which convey food. They are responsible for performing numerous functions of utmost importance, including the digestion of the food we eat, the extraction and absorption of the vital substances contained therein, the excretion of waste products, as well as play a crucial role in the defense of the body. But the organs of the GIT are tubes. We said they are tubes. How could they perform so many functions? Well, I'm so glad you asked. The trick lies mostly in the walls of these nifty tube organs. The GIT are the esophagus, the stomach, small intestine, and large intestines, as well as the rectum and anal canal. The esophagus extends from the pharynx to the stomach. It might be the only organ of the GIT which is found both within the thorax and the abdomen in most healthy human beings. It enters the abdomen through the esophageal aperture at the level which is equal to the 10th thoracic vertebrate. Abdomen through the esophageal passage. The stomach is found on the left side of the abdomen and begins at the gastroesophageal sphincter and empties into the small intestine. The small intestine is made up of 3 consecutive structures which are histologically different from each other and perform different functions. They are the duodenum, into which the stomach empties, which is the shortest of the small intestine tubes, the jejunum, and the ileum, which terminates at the ileocecal junction. The large intestine is the next tube in the series of tubes, a series of U-tubes, if you will, and it consists of the cecum, from which the latter part of the word ileocecal originates, the ascending large intestine, the transverse intestine, and the descending intestine. The last tube in the GIT is the rectum. And and then followed by the anal canal. The so-called accessory organs are, as their name suggests, an accessory to the GIT organs, meaning one of the functions that they have is to enhance and support the function of the GIT organs. These organs are the liver, the gallbladder, and the pancreas. The organs of the alimentary tract and their accessory organs are mostly found within the abdomen, where, like most organs of the body, they have a lymphatic drainage, a blood supply, as well as innervation. These structures, as well as their location in relation to each other and the GIT organs, are important as well, so you would do well to study them. Embryonically, the organs of the alimentary tract are divided into the fore, mid, and hind gut. The organs of the foregut are the esophagus, the stomach, the proximal half of the duodenum, the liver, the gallbladder, and a part of the pancreas. The midgut consists of half of the duodenum, the jejunum, the ileum, the cecum, and the appendix, as well as the ascending colon and the proximal 2/3 of the transverse colon. The hindgut is the distal 1/3 of the transverse colon, as well as the descending colon, the sigmoid colon, as well as the rectum and part of the anal canal. Now, why is this important? Well, despite you being way past being a fetus, your GIT was formed sometime during your embryo-fetal days, and as a result, some things about it never changed. One of those is that the distribution of the blood supply has kept the same. So, most of the foregut, which is the embryonic term for these organs, is supplied by the celiac trunk. Most of the midgut is supplied by the superior mesenteric artery, and most of the hindgut is supplied by the inferior mesenteric trunk, all of which are branches of the descending abdominal aorta. The descending abdominal aorta. The branches of these trunks form very important anastomoses. We aren't going to discuss these extensively. The venous blood supply of the GIT and its accessory organs is also very interesting and of severely important clinical significance. The organs of the alimentary tract also have dual innervation. They have an intrinsic innervation, which allows for quick responses and adjustments in the GIT in response to different changes, such as the presence of food of different compositions, as well as other changes within your GIT. I said 2 sources of innervation. So they also have an extrinsic innervation, which ensures that the intrinsic innervation is coordinated to ensure that the GIT is optimally functional. Both of these are important because your intrinsic innervation is located within the GIT and can make rapid adjustments to the GIT and the changes it is experiencing. But the extrinsic system is also of great importance because it ensures that your intrinsic nervous system or your intrinsic innervation does not go rogue and become ineffective. Moving on, you remember how we talked about how GIT organs are tubes? Well, what is so special about these GIT organs and their walls that allows them to perform so many important functions? Well, the walls of the GIT organs have histologically 4 layers. These 4 layers are consistent throughout the GIT, although adapted in each organ to perform its function. The 4 layers of the GIT wall are the mucosa, the submucosa, the muscularis, and the adventitial or serosal layer. So, quick recap. The gastrointestinal system and alimentary organs are a series of organs whose responsibilities are many and include ensuring that you digest food and extract and absorb all the substances which are needed by the body from it, that you excrete waste products, and that you have at least partly some immune defense against foreign organisms and foreign objects which would wish to harm you. So, in our next video, we will talk about the histology of the GIT. Warning, we are going to enter the GIT histology zone. Well, thank you for watching our video, and we shall see you in the next one.